So let's take a look at some calculations for probabilities using the normal distribution. So this question says, assume that a randomly selected subject is given a bone density test. Those test scores are normally distributed with a mean of 0 and a standard deviation of 1. Find the probability that a given score is less than 1.95 and draw a sketch of the region. So anytime you're dealing with normally distributed data, it's going to look like these pictures down here. It's going to be a bell-shaped curve, that symmetric bell shape that we've talked about, and it's going to consist of two parts. There's going to be this line down here at the bottom. That's where the data values will go. And then there's going to be these areas, these shaded regions up here on the top under the curve. Those are the probabilities associated with different data values on the bottom. So for a question like this, we know that the mean of this data is 0. So that means that 0 would go right here in the middle of this bell-shaped curve, right where the highest point is. We just mirror that down here onto this bottom axis, and 0 would be right there, with numbers less than 0 going this way and numbers more than 0 going this way. The standard deviation is 1, so that tells us how spread out the data is, meaning is this bell-shaped curve very tall and skinny, or is it more flat like this? So the standard deviation tells us how skinny and tall or wide and flat this bell-shaped curve would be. So for this one, we're supposed to find the probability, that means find the shaded area, that a given score is less than 1.95. So if I look at all these different options, I see 1.95 down here in the bottom axis for everything. So the correct graph is going to be letter A. So here's 1.95, and then the area that's been shaded is the area less than, or to the left of, that 1.95. In these graphs, less than means to the left, more than or greater than means to the right, and between, of course, would mean between two values that you would be given. So less than would indicate this type of picture. Now we want to know what the probability of that is. In other words, what is the area of this blue shaded region in this graph in letter A? To do that, we can use Statcrunch. So we're going to go ahead and open it by clicking Get More Help, Statcrunch. The normal distribution calculator is under Stat, Calculators, Normal. And you can see that it's going to bring up that exact same type of picture with that bell-shaped curve. So the first thing we want to do is put in the mean and standard deviation. Remember, this question said that the mean was 0 and the standard deviation was 1. So that's already in here for us. Of course, if it was a different mean and standard deviation in the question, you would just type whatever it is here and here. And now we want the probability that the value, our data value, is going to be less than, so we can leave this as a less than, 1.95. If we wanted to, we could change this to greater than, but we weren't asked for anything greater than in this question, so we're going to leave it as less than, and then we're going to click Compute. And notice that we have basically the same type of picture that we have here in letter A. It doesn't matter about the colors or anything. So the probability, meaning the area of this shaded region, is given right here. So I can go ahead and copy this and paste it over here into my math lab. And we wanted to round to 4 decimal places. So 1, 2, 3, 4 would be this second 4 right here. I look one digit after to see how I need to round, and that 1 tells me to round down. So the probability associated with a bone density score being less than 1.95 is 0.9744. In other words, there's a 97.44% chance that someone who was randomly selected would have a bone density of less than that amount. Now let's try this one. This one says, assume that thermometer readings are normally distributed with a mean of 0 and a standard deviation of 1 degree Celsius. A thermometer is randomly selected and tested. For the case below, draw a sketch and find the probability of the reading between 1, and 2.25. So again, normally distributed means we have a bell-shaped curve. The data values would go on the bottom axis, and the areas or probabilities associated with those data values would be up here in this shaded region under the curve above. So we're looking for something between 1 and 2.25. So that's going to be letter B right here. We see the 1 and the 2.25, and we have shaded in the blue between those values. Now we want to get the probability of that happening. So for that, we can go to Statcrunch. Again, the normal distribution calculator is under Stat, Calculators, Normal. For this question also, the mean was 0 and the standard deviation was 1. And now we want to choose a value between, so we're going to click between up here at the top, the two values given. So 1.00 and 2.25. And if we click compute, it's going to give us that area right here, and the probability or the area associated with that is this 0.146. So I'm going to copy that and paste it over here, and again we want 4 decimals, so 1, 2, 3, 4. The 3 in the next position says to round down, so we're going to leave that 4 as a 4. Last type, this one says find the indicated IQ score. The graph to the right depicts IQ scores of adults, and those scores are normally distributed with a mean of 100 and a standard deviation of 15. So they've already given us the graph in this case. So we basically want to know the probability, or rather we want to know what IQ score. See, the value down here is an IQ score that we don't know. It's an IQ score or a data value because it's on that bottom axis. And what they're telling us is this shaded area up here. So this is the probability that a person would score higher, right, to the right of that score. So we know the probability this time, but we don't actually know what the score was. But we can still use the same place in Statcrunch to help us solve this. So again, it's Stat, Calculators, Normal. So this time we had a different mean and standard deviation. This time they said the mean was 100 and the standard deviation was 15. In the prior two examples, they told us what this value right here was going to be. Remember, those were the value or values that were down here on the data line on the bottom. But this time they didn't give us that. This time they gave us the probability, so it should go here, 0.1587. That's where the probability goes. And we want to know this is associated with being greater than this missing value right here. So I'm going to change this to greater than to indicate that. So see, now we got this picture, and we have the exact same picture right here, right? This shaded region over to the right, same as here. The area in that shaded region is 0.1587, same as it was here. So this value down here, this IQ score that's separating the graph in this way, is going to be this value, 114.99. So we're going to copy that and paste it over here. This says round to the nearest whole number, so we don't want a decimal point or anything after it. So we're just going to look at the 114. The number that comes after the 4 is a 9, which means we should round that 4 up to a 5. So the indicated IQ score is 115.